Sample problem S09-07. Two boxes are tied together by a string and are sitting at rest on a frictionless surface. Between the two boxes is a massless compressed spring. The string tying the boxes together is cut and the spring expands, pushing the boxes apart. The box on the left has 4 times the mass of the box on the right. A, after the string is cut, is the magnitude of the momentum on the left greater than, less than, or equal to the magnitude of the momentum on the right? Well, the total momentum, of course, at the start is 0. And the system momentum at the start is 0. And that will mean, since the spring is internal, that the total momentum after is also 0, right? Initial and final, which means that the 4m times its velocity, let's say that it kicks off with a velocity v1 in that direction, and the 1m goes in velocity v2 in that direction, then our momentum after release is 4m times minus v1 plus m times v2. And we know that that has to equal 0 because the system momentum is 0 and stays that way. So we want the velocity, we want the momentum on the left, which was just p1, so minus p1, and the velocity momentum on the right is p2, and we see that that means their magnitude of the momenta will be equal. On the other hand, what I was in the middle of doing up here says that we can use this to turn around and say, well, then v1 is going to be m over 4m v2, or 1/4 v2, which means that the guy on the right, the one on the left is moving with a lesser speed than the one on the right. This is a general truth. If two things start off from rest together, the lighter object moves faster.